Before learning about roadside turfgrass installation and maintenance, it is important to understand the history of roadside turfgrasses, as well as the stresses that are common to roadsides. Roadsides take up a lot of land. For instance, inside the 494-694 loop of the Twin Cities, there are over 175,000 acres of roadside vegetation. And statewide in Minnesota, that number climbs to well over 250,000 acres. Even in a metropolitan area, there are many different types of roadside uses of turf. The top left picture shows a busy urban interstate. The picture on the upper right shows a quiet residential street without sidewalks. At the bottom, there are examples of turf between trails or sidewalks and streets. All of these sites benefit from turf that is dense and functions properly. There are a number of reasons that these thousands of acres of roadside turf are important. First, mowed vegetation provides better visibility, increasing driver safety. In addition, dense vegetation, such as turfgrass, can help filter pollutants from water and help stabilize the soil to prevent erosion through a fibrous root system. Turf also provides a cooling effect next to pavement. When soil is held in place by turfgrass roots, there is less risk of dust being released from roadsides. Finally, a nicely maintained roadside is visually appealing. Turfgrasses have been used on roadsides for close to a century, both in the U.S. numbered highway system and abroad, such as in the Autobahn in Germany. At that time, it became clear that the fibrous root system, spreading growth habit, and mowability of turfgrasses would all fit well in a roadside environment. In Minnesota, the Department of Transportation specifies the use of turfgrass wherever it might be necessary to keep desirable views open while maintaining consistency with turf types and care found along bordering land uses. So, we know that turfgrasses can provide important functions on roadsides, and they have been used for more than 80 years. Nevertheless, vegetation managers struggle with maintaining these sites. There are a number of reasons for this. First, these sites are very low input, so they often lack sufficient moisture for a healthy turf. They are typically quite a bit warmer than other turf areas due to their close proximity to pavement. Soils on these sites are often compacted and lack proper nutrition. Biotic stresses, like diseases, are often a problem, and the means to control these living pests are usually not available due to budgetary constraints. These three stresses, though present, are not the major stress of roadside turfgrasses in northern climates. The major stress that we will now discuss is damage from road salt. These salt applications during the winter result in significant turf damage during early spring. The area of turf right next to the road receives a significant amount of snow and salt from plowing operations. This image shows snow piled up on the turf area between a trail and a county highway in an exurban community north of Minneapolis, Minnesota. Here is the site after snow melt in the spring. There are signs of weed invasion, compaction, and turf death. The primary salt applied to roads is sodium chloride. In the 1940s, sand was the primary means of dealing with ice on roads. Sodium chloride began being added to sand piles to keep it from freezing in the winter. In 1941, New Hampshire began to use sodium chloride as a regular road maintenance practice. This graph shows the increase in roadside salt sales, which is an indicator of actual applications, after sodium chloride first began being applied in the early 1940s. The overall use of road salt has increased in the United States. The amount of salt applied to roadsides is quite staggering. In the Minneapolis-St. Paul metropolitan area, as of 2007, about 350,000 tons of sodium chloride were applied each year. The salt is applied as a pre-wetted granular sodium chloride that is distributed with a rotary spreader. A typical rate of application is about 33 pounds per mile per lane. But of course, this amount can vary depending on the conditions of a particular road. This chart shows how sodium chloride concentrations in the soil change during the year in Minnesota. As the spring rains come in May and June, salt levels drop, and then rise back up again as soon as the chance for snow and ice returns in the fall. This figure also shows how the area closest to the road, the left of the 3 bars for each month, has the highest levels of salt. This is one reason that damage from salts is often worst nearest to the road. There are a number of ways that salt can affect living vegetation. First, if salts accumulate over time in the soil becomes saline, which means it has a lot of salt. As these salts build up, they can eventually change the structure of the soil so that plants don't have access to as much water and air. In non-arid regions, this is not as much of a concern because the rains in spring usually help move the salt through the soil. This is referred to as leaching. Tissue desiccation is when the salt sort of dries out the plant when it comes in contact with plant tissues. The salt has a chemical structure that essentially pulls water out of the plant. This is the major problem on most roadsides. Finally, the plant can take up salts through roots, and the chloride ion in particular can be toxic in the plant if present in too high of concentrations inside of cells. Sodium chloride also has a negative impact on water bodies near roadsides due to runoff and leaching. For that reason, researchers are testing out a number of alternative de-icing materials. The challenges for creating a fully functioning roadside turfgrass are difficult to overcome, but armed with sufficient knowledge, success is possible. During this course, you will be led through a series of modules that will teach you about roadside turfgrasses. First, you will learn about the grasses that should and should not be used along roadsides. Next, you will learn about soils and how soil properties affect the success of a roadside. After that, you will learn how best to establish a roadside through either seeding or sodding. The next series of modules will focus on important management considerations, both during and after establishment, such as mowing, irrigation, and fertilization. The last modules of the course will introduce you to common weeds and diseases that are found on roadsides and some options for reducing their effects. The course will wrap up with a case study exercise that will allow you to use the knowledge you gain in the course to solve a real-world roadside turfgrass problem. We hope you are convinced that roadside turf areas provide important functions. Knowledge of the stresses common to roadsides will help you properly establish and manage these important landscapes. Turfgrass selection and management are important steps to creating a successful roadside turf stand, and we will cover these topics in the remaining modules. Thank you for viewing the Introduction to Roadside Vegetation. In the next module, we will discuss turfgrass species for roadsides.